This is Beyond the Blue Badge, brought to you by the Microsoft Alumni Network, where we dive into Microsoft alumni stories that inform and inspire.
Welcome to another episode of Beyond the Blue Badge, the Microsoft Alumni Network podcast. I'm Becky Monk, CMO for the Microsoft Alumni Network, and with me today is Larry Hryb.
Hey, Becky, great to see you. We were rolling into spring. It's beautiful outside, and we've got another great show lined up for you. Today, we are diving into the fascinating journey of Microsoft research. We're going to be exploring its foundation, growth, and the groundbreaking accomplishments that have shaped the tech industry.
That's right, Larry. Microsoft research has been a cornerstone of innovation, driving forward the frontiers of knowledge and technology, not just for Microsoft, but for the world. And we'll be hearing from three key figures who played pivotal roles in this development: Dennis Adler, Dan Fay, and Rick Rashid.
Now let's start at the beginning. When Bill Gates proposed the idea of starting Microsoft Research to the board of directors, he emphasized that establishing a dedicated research division would enable Microsoft to stay at the forefront of technological advancements and collaborate with leading academic institutions and researchers worldwide. This was a novel idea. At that point, software companies tended to be fairly small, and computer science research labs were primarily associated with hardware companies of large established entities like AT&T or Bell Labs. Stable companies with big income streams that could make those kinds of investments. For a small startup software company to make that kind of investment to create long-term basic research was unheard of.
Right. The first step was to find the right person to run this new group. Nathan Myhrvold and Gordon Bell headed up the search and sought out Rick. Gordon and Rick had crossed paths when Gordon had worked at Digital Equipment, and Rick was a professor of computer science at Carnegie Mellon University. Rick had already made a name for himself as a developer of one of the first networked computer games, AutoTrack, and he was the developer of the Mock operating system. It all started with a phone call from Gordon to Rick one night around dinner time. And let's just say it wasn't an easy sell to get Rick to become the first director of Microsoft Research.
I wasn't particularly convinced at this idea of Microsoft creating a computer science research organization because I knew how hard that was to do. And I wasn't sure that a small company like Microsoft would be capable of doing it or even really understood what it meant. But, I listened to Gordon. He convinced me to have him and Nathan come to my office, and talk to me more about it. So they did do that. And again, he didn't quite convince me at the time, but they convinced me enough that they, come out to visit us, right? Come out to see Microsoft. So I went to Microsoft and I met with Nathan. Of course, I met with many of the Microsoft executives at the time. And I was incredibly impressed with the people I met. One of the things I think in those days at Microsoft, everybody was just amazingly smart. And I don't just mean they knew how to write software or they were technically smart. They actually understood computer science extremely well. Many of them had read the literature quite well, right? So they were knowledgeable both about technology development side of computer science, but they knew a lot about research. I mean, Jim Alchin, who was there at the time, I had a fantastic conversation with him, and it was very technical, very focused in research. But I wasn't particularly sure. Then I went to talk to Bill, and we spoke for probably an hour and a half, I think maybe longer than was originally intended. And what amazed me about that conversation was that I sort of went in thinking, okay, Bill doesn't really probably understand what we're really talking about doing for a computer science research organization. But really, no. I mean, pretty much every part of the conversation I had with him, he and I were very much in sync on what this meant, what would need to be done, how we need to be built, how it would be organized. I was just blown away. All that being said, I went back to Pittsburgh, and I still told Nathan no. And the reason was because I had a lot of loyalty to Carnegie Mellon. And, I built up a large research group there, doing the mock operating system and all the things that went around with that. And I just felt sort of an obligation to the people that, had brought me into the department and supported me. And then it became even more complicated because they were in the process of turning computer science department into a school of computer science, and they wanted me to be the dean of the school. And so then I wound up with like two different new opportunities. Should I be, dean of this new computer science department, or should I start this computer science research organization at Microsoft? And during this time, Nathan just kept, coming back and coming back. And my understanding was internally, Nathan would refer to me as Dr. No, because I kept telling him no. But he's really, if you've met Nathan, and you may have, he's not one to really take no for an answer, right? So he would keep trying. And it got to a point where there was a particular day that I said, look, I'm just going to make a decision. And it sort of wound up being, I realized that part of the reason I wanted to stay at Carnegie Mellon had a kind of a guilt component to it. And I thought, this Microsoft thing, it could be a lot of fun, right? And I sort of, so there's guilt here and there's fun here, right? And which should I do, right? And for people who know me, I'm way more of a fun person than I am a guilt person.
It may not have been an easy sell, but when he did agree to do the Microsoft thing, he jumped in. And one of the first things he did was create a mission statement that set the tone for what the group would do.
The approach that I chose to take and that we took in Microsoft Research was one of doing fundamental basic research. So by definition, it was defined to not be something that necessarily applied to Microsoft. I mean, in fact, I developed really sort of a mission statement, about Microsoft Research. That was the mission statement we had for the entire time that I ran the organization, and I believe they still have it today. And the first part of that was our goal was to do fundamental basic research and push forward the frontiers of knowledge in the areas that we do research. And there was nothing about that said anything about Microsoft or any practical use. The goal was we really needed to push the state of the art and move things forward. And my belief was that unless we were doing that, we would not ultimately be that valuable to Microsoft. I mean, in a sense, the notion here was we needed to create things that were going to be a real long-term value that could help sustain the organization in periods when it needed new ideas and new technologies and people who were capable of pushing the company in a new direction. The second part of our mission statement was once we developed an idea or created a technology, to work as hard as we could to move that technology into use, into product. And so, but that was really the second step. It didn't impact what we worked on. It's like, if something made sense, then we would put all of our energies into trying to make sure that it really did have an impact. And the last part was really to ensure that Microsoft and really, our society really had a future. Because if you think about the role of basic research, it's kind of like an insurance policy for the future. I mean, if the technologies change, if the economy changes, if there's a new disease or a famine, all sorts of things can happen, right? New competitors in a company perspective. You want to make sure that you can change, right? that you can adapt, that you can survive. And you do that both with a treasure chest of ideas and technologies, but also with a treasure chest of people, who are, the top people in their respective areas.
With the mission in place, he set out to build a team that could innovate and then help get those ideas to the product teams.
That's right. Rick had a really great example of how the basic research his team was doing could eventually pay off for the company. Let's take a listen.
But I think there was a lot of both going on all the time. An example of inventing something that the product teams didn't initially even want. Again, back in the very early days of Microsoft, during the 1992-93 period, some ideas that actually originally started with Nathan Myhrvold and Gideon Yuval within Microsoft Research. They had this idea that you could compress, you could reduce the working set size of 32-bit programs by breaking the programs into tiny building blocks and then rearranging them based on how the program's executed in time. And the idea was that you'd measure how programs behaved. You would run these algorithms to try to figure out what would be the optimal way of laying out these basic blocks in the programs. And then ideally that meant that parts of the code that didn't usually get executed wouldn't be in the working set of the programs, and so you use less space. So a number of people worked on that. I got involved in helping to kind of drive the development of it with several people. And we got to a point where we were able to demonstrate pretty convincingly that we could have a significant impact on the working set size of 32-bit programs. But I remember going to the product teams with these ideas, and they would kind of look at us and say, we'd have all this math. I mean, there's just a huge amount of math on the boards, right? And they'd look at us and say, you guys are just really smart. I mean, you're just incredibly smart. But we don't actually have this problem because back in those days, Windows was built on 16-bit code, right? So, but you guys are really smart. And I'm sure if you keep working, you'll someday do something that we actually need, and thanks for stopping by and playing our game. That's how it mostly went, with the Windows and the Office teams, except for the Windows NT team. And those guys are incredibly smart guys, and they understood what we were doing, and they had 32-bit code. So that wasn't the issue. But they didn't really like this idea that, we were going to rearrange their software, And I remember after what I thought was a great meeting. I mean, they completely understood the math. Everything was great, right? We get to the end of the meeting. I thought these guys are definitely going to want to use this. And Dave Cutler came to me afterwards and said, "You're going to do this to my operating system over my dead body." And if you've met Dave, or if you met him back in those days when he was a younger man, he was being totally serious about the dead body thing. Okay. He was way bigger than I was. He was much more intimidating. Now, fast forward a few years, and now we're 1995-ish, 94, 95-ish. Because of various trade issues with Asia and things like that at the time, the amount of RAM that was available in PCs in those days had not really grown the way you would normally expect to have grown. And so we were getting into a situation where we now had a 32-bit version of Windows 95. But the size of memory on PCs of those days was sort of 4 to 8 megabytes, not gigabytes, okay? Keep in context for the time. And it just wasn't going to work, right? You weren't going to be able to run that and run Office and still have that be a viable experience for someone. But the good news was that we have this technology and we continue to develop it. And Bill Gates, Nathan, incredibly supportive of all this. They'd been supportive of us, continue to develop it, continue to work on it. We literally were doing parallel builds. We had refined the technology so that it could be used in production. And so we worked with them, and we were able to bring that Windows 95 and Office, 95 to market and run them on machines that were, much less capable because we had this technology that reduced the working set size by about a factor of 2. I mean, years later, various people would tell me, like, say Lotus, right? Lotus, WordPerfect, they didn't have this technology. They couldn't run in these smaller systems. It was a tremendous disadvantage to them. So it was really a technical advantage for us. And they said, well, we knew you were doing something that made your office work better, but we didn't know what it was, right? And I think that was something where originally the product teams didn't want the technology. They didn't think it was relevant to them. But times changed. Something happened, right, that suddenly meant that they had a problem, and this was a solution for that problem. And because we'd worked on it and believed in it and continued to invest in it, it was available to them when they needed it. I eventually, for Windows NT, I eventually got a great note from Dave Cutler, which basically said, I want to thank you guys for all the hard work you put into this. We couldn't have shipped without you. So I mean, it was, again, that's a very simple example of investments in research, which originally was just basic research, but then eventually had this incredibly practical effect because of a change in the environment, a change in the way the world was functioning. And I think that's really where research is valuable. If you're only investing in things that are going to pay off, then you're going to be missing the most important opportunities.
There are dozens of great stories like that. Microsoft Research was clearly making strides within the company to prove itself, but it was 1996 when the outside world really started taking notice.
That's right. You've heard of Publish or Perish? Well, SIGGRAPH was one of the most important computer graphic conferences at the time, and top researchers were selected to present their papers. Rick and Nathan Myhrvold had just received word that Microsoft Research would have a major presence there that year.
In that year, more than 25% of all the papers in the conference had a Microsoft Research author. And I can remember, this has never been done before, right? This is like extremely unusual to have a single research lab have that kind of influence on one of the top conferences. And I remember going into Nathan Myhrvold's office at the time, and I'm sure we were thinking exactly the same thing because we both had gotten this news, and we just looked at each other and just started laughing. It's like, we'd made it, right? This was a coming out party for Microsoft Research because people realized, like, here's this research lab. It's only been going for 5 years, right? And yet they're suddenly having this big impact in this conference. And then you start to see other conferences, other major conferences in other areas having, 15, 20, 25%, Microsoft Research authors. It's like, who are these guys, right? But there was that was a point in time where it became clear that Microsoft Research had become a significant player, in the research world.
That was also the time that Microsoft Research started to expand in a pretty extensive way, right?
Yes. At the time, they had about 100 researchers, but coming off of that SIGGRAPH success, Bill Gates was excited about the idea of expansion. Let's listen to Rick tell that story.
Bill sent me an email basically saying, okay, you guys are doing great. I want you to triple the size of research. Now, I think Bill may have been thinking more in terms of how product groups work, because you could grow a product group fairly quickly, right? You can't grow a research group that fast. It takes way longer. But, I said, look, Bill, I can't do it that quickly, but we can grow and we will grow. And that's when we also started making investments outside the United States, because there was a limit on the amount of talent, we could access just within the United States in any given year. But, we started our research lab in Europe, in Cambridge, England. We started a research lab, another year later or so in China, in Beijing, Microsoft Research Asia. And so now we were able to sort of geographically expand, right? And we could bring in many more researchers from new areas of the world. So we could tap into people who really wanted to be in England or in Europe. We could tap into the Chinese, young Chinese researchers. We could, and then, after that, we eventually started a lab in India. So we started growing, but not just within the US, we grew broadly. And again, that allowed us to bring in a lot more talent than we would if we'd only confined ourselves to the United States.
Rick's leadership and vision led to the establishment of multiple research labs around the world, including in Europe, China, and India. When he retired, the number of researchers had increased to around 1,200, rivaling the size of fundamental basic research labs at MIT or even Carnegie Mellon.
Dennis Adler was one of the developers at Microsoft that requested to work with Rick at Microsoft Research.
I spent the next 10 years of my career until I retired there. And it was the thing that was amazing for me. It was like getting an honorary PhD in computer science. I learned so much. I had no idea about how language models worked, or about how you would take the pixels in a video array that were coming on to the screen and decide what's the outline of the person, where are their eyes, where's their nose, mapping that, bit mapping that onto a 3D surface and showing what that projection would look like, processing natural spoken language and figuring out the parts of speech. Microsoft Research encouraged everyone to publish. We still got patents before we published, but we published. All the companies I'd been at before, you held trade secrets really close. You didn't want to let people know what you were working on. I liked the idea that we were doing all this work and sharing it with the world, trying to advance the state of the art while we advanced our own OS, our own products. And that seemed pretty unique.
Another person who was a longtime member of the Microsoft Research team is Dan Fay. His work at Microsoft Research focused on bridging the gap between academia and industry, helping researchers leverage Microsoft's technology to advance their work. One of the things they did was work on high-performance computing and grid computing, helping universities and researchers use Windows in these areas. That led to the development of Windows HPC and later Azure for Research, enabling scientists to run their computations in the cloud.
When the cloud computing kind of shift happened, one was that there had been work in, I'll say, national labs and other areas of this thing called grid computing, which was how could they at national labs share their machines between different research sites. And this was something that, again, we had identified, and I brought and presented internally to folks to say, hey, here's something we should be aware of. This is happening. They're trying to figure out how to use this stuff across the internet and across these networks and share their material or their resources. And so that this was kind of ongoing. This was a way to help solve some of the science problems that they were looking at. And then at the time when cloud computing was kind of coming up, it was a very similar thing to say, okay, hey, we have this asset, you could use it for your science or your research. The challenge had always been when they started looking at it was the cost, because with academics, and what you did was you bought a machine and you paid for all that and got up and running, but they didn't pay for anything else. They didn't pay for the electricity or some of those things. And so it was felt like a one-time sunk cost. Whereas with cloud computing, it was this ongoing cost. So there was a real hesitancy to why they should use it. And so one of the things we were looking at was also, hey, how could we get them to use it? How could they benefit from it? And what could we learn as a company in this space as well from them and how to use it? It was one of those things recognized early on that it was, hey, this was like the new OS for the internet or for the web. And so had sat down and actually penciled out a program called Azure for Research, and ended up bringing this at the time to Satya, who was the head of Azure at the time, getting his approval for it, and then moving forward and getting it kind of rolled out to different universities and researchers around the world.
There are so many innovations that have come out of Microsoft Research, too many to talk about here. It would be great to wrap up with Rick's favorite innovations during his time at Microsoft Research.
It's a great one, Larry. One that stems from an initiative that Rick started in 2008. But it's one that we're all just really getting the benefit from in these last few years. Let's take a listen.
I'd come up with this feeling like I needed to do something to try to help stimulate people to really push the state of the art. And I thought, we should just be doing more, give people license to do really out there kinds of research projects. And so I came up with this notion of the Impossible Things Initiative. And the idea was, I had this memo and I sent it around. The idea was that it goes back to the Lewis Carroll's, impossible things before breakfast, right? That we should look at some things that, in some sense you could say at that instant in time were impossible, but that could be a stimulus for ideas that could have an impact later on. And one of the few that I spent some time writing about in that memo was the idea of doing this speech-to-speech translation. And I said, look, every year I go to China as part of our 21st Century Conference that we'd run for, tens of thousands of Chinese students each year. And I'd get up on stage, I would give my speech, but there would be translators, human translators in the back that would do the translations. And what if I could get up there and give my speech and have a computer system do the translation? And to do that, as I'm speaking, so that people could hear me speak, in Chinese. And at the time, that really seemed very far from possible. I mean, the speech recognition systems of those days, just the recognition part, had pretty significant errors. And so it seemed like it was going to be really hard to make work. Now, I remember, in fact, after I'd sent that memo out, one of the things I would do, is I would have lunch with various teams of researchers in their cafeteria. And I would mostly I'd go in the cafeteria, I'd just sit down with groups of people, and we just talk. And that particular day, I happened to sit down with the speech recognition team. And, I remember, one of the young researchers was basically just haranguing me and saying, look, this is not possible. I mean, the rate of progress in speech recognition has been just, turtle slow, for the last 15 to 20 years. And, what you're talking about isn't going to happen for more than a decade. And in terms of just the recognition part. And so, he just kept going on about why this wasn't going to work. And I kept giving, suggestions. Well, I'm a really, when I speak in public, especially when I speak in a foreign country, I speak very methodically. I'm from Iowa, so I have a fairly nondescript accent. So it's not that difficult to understand me. You have, thousands of hours of my speeches already. So you've got a lot of data to work from. You have a pretty good idea of what I'm going to say, because in my speeches, I often say the same things. I kept giving you reasons why this may not be as hard a task. You could cheat here, you could cheat there, or whatever. I didn't convince him at all, but I felt it felt weird in my mind that here was this young researcher that was basically saying something was impossible, and here's this old guy basically saying something you could be done, right? This is the reverse of usually how you expect the relationship to go. But the teams worked really hard, both in China and the US. They actually worked on this pretty hard. And a couple of years after I sent the memo out, they thought they'd gotten things to a point where they could make a go of it, right? So they came to my office. I tried the system out. We experimented with it on stage in China, and it just didn't work. I mean, it kind of worked, right? But the problem was it would make mistakes that seemed really crazy. And I said, look, I don't want to be the Microsoft executive who gets translated into saying some offensive thing, in Chinese. This is not going to work for me. And the team was very disappointed, but I said, look, it's not ready. We're not going to do it. But they kept working on it, and they started incorporating new ideas and new technologies, right? So this is when we began to bring forward the notion of using these deep neural networks, and working with people like Jeffrey Hinton and some of his team in trying to adapt deep neural networks to this particular task. And some of that was the actual network technology. A lot of it was actually the technology for training the models, because it was painfully slow to train these models. So they had to develop both techniques for using graphics cards of the day to accelerate the training, but also to develop networking technologies so they could get large numbers of machines simultaneously working on the models. So they could reduce the training time from like 6 months to weeks, right? Which is an important part of this. So again, fast forwarding to 2012, I got on stage in Tianjin. Well, I should go back. Earlier that year, they came to my office with their new version. And I knew things were great when we'd accidentally left the system on and we were just chatting, and it was transcribing everything we said. And it was incredibly accurate. I said, okay, this is looking really promising. I went on stage in China, and as I said, I spoke some amount of my speech in English. It got translated into Chinese, and they'd gone the second step of making the Chinese sound like me, right? Using my voice to help modulate it, and it was just it was tremendously influential. It basically proved that you could do this, and I think it empowered not just researchers in Microsoft and product teams at Microsoft, but also researchers around the world and product teams around the world to say, oh, you can make this work. We have an idea now that this can happen. And I think that was extremely influential. It was exciting. I mean, I must admit, even from my perspective, I didn't cry on stage, but there's an energy when you create something new and you're able to demonstrate it for the first time, and you can see the audience visibly affected by it. There's an energy that goes with that, and and excitement. And I've luckily had that experience a number of times in the past for things that I've done, but it is again very gratifying.
There are just so many things for Rick and all of the people who've worked at Microsoft Research throughout the years to be proud of. Microsoft Research has grown significantly, becoming one of the largest, most influential research organizations in the tech industry. Its contributions to AI, to cloud computing, and various other fields have really shaped the future of technology.
That's so true. And Microsoft Research continues to drive innovation, and its legacy will undoubtedly inspire future generations of researchers and technologists. We want to thank Dennis Adler, Dan Fay, and Rick Rashid for sharing their incredible journeys and insights. That's all for today's episode of Beyond the Blue Badge. If you enjoyed this episode, be sure to subscribe. We'll be back soon with more stories from Microsoft alumni who are making a difference in the tech world. Thanks for watching.
Thanks for listening to today's episode. If you like what you're hearing, be sure to subscribe to the podcast on your favorite podcast app. Make sure you leave a rating and review and share it with someone you know. We hope you join us again for the next episode of Beyond the Blue Badge.